Hassler here. I'm going to work through the 7-6C Explore. And what we're going to do today is put together the idea of finding and factoring out a greatest common factor, along with factoring trinomials. So we're going to put those two ideas together, along with a couple of other things, and then you'll have the opportunity to practice. So the box says we have multiplied factors together, and we have now broken polynomials into factors. We've also divided out a greatest common factor. So let's see how to divide out a GCF and then break an expression into two factors. All right, so the first question that we have here says, our f of x equals x squared minus 7x minus 44, and g of x equal to the quantity x plus 11 times the quantity x minus 4, equivalent functions. Explain. And I could do one of two things to check whether these are equivalent. I could either start with f of x and factor to see if I get the same set of factors as g, or I could take g of x and I could multiply to see if I get the same standard form as f. So those are my two choices. And I'll show you both of them just so you can see how this works. So for f of x, if I want to factor, I got to find numbers that multiply to negative 44 and add to negative 7. And I'm going to break this down into two groups that are getting multiplied. So x squared breaks down into x times x. Some factors of negative 44 would be like negative 1 times 44, or the opposite, right? 1 times negative 44. And I'm thinking about like negative 4 times 11. And I need these to add to negative 7. Okay, so the negative 1 and 44 are not going to work. But negative 4 times 11, if I add negative 4 plus 11, I'm going to get a positive 7. And I want a negative 7. So what that means is I need the 4 to be positive, and I need the 11 to be negative. Okay. And you can either do a check by multiplying this out, or you could do a check by graphing on Desmos, graphing the f function and graphing your answer and making sure that they match. Or it can multiply out, and we've talked about breaking it apart or the box method. What you're really doing is multiplying each term in group 1 by each term in group 2. And so when I combine those like terms, I get x squared plus 7x minus 44. And so now I'm going to go through and check, does this x squared plus 7x minus 44 match the f function? No, because that middle term was positive and the f function has a negative middle term. Or do the factors that I got for f match the factors of g? No, the factors have opposite signs. And so my overall answer is no. And you can either use the factoring method or the multiplication method to verify. 2 says, write each quadratic expression in factored form. And so again, this is a review of what we've done. To write in factored form means I'm going to write two groups being multiplied together. I'm going to find factors of 36. There's a lot of them that add up to 13. And so x squared is x times x. And I believe the factors that work are x plus 9 and x plus 4, because 9 times 4 is 36. And then if I do 4x and 9x, I get that 13x, okay? In B, I'm going to split this up, and I get x and x, okay? And I need factors of 10 that add to negative 7. I think negative 5 and negative 2 will work. I noticed that I have to multiply to a positive, so the signs have to be the same, but I'm adding to a negative number, so they should be negative numbers that are getting added. And again, if I check this, negative 5 times negative 2 gives me that positive 10. But when I check my numbers, I have a negative 2x and a negative 5x. I get negative 7x, so it works out. And finally here, if I factor this, I get I get not x squared. I get x times x in my two groups. And I need factors of negative 8 that add to negative 7. I believe this is going to be x minus 8x plus 1. And again, if I do my check, negative 8 times 1 is negative 8. And if I check my x terms, I have 1x minus 8x, which gives me that negative 7. Okay, so that's just a quick review of the factoring that we've done. And so let's do question 3. It says, consider the function f of x equals 2x squared plus 4x minus 48 written in standard form. And how is this function different from the ones you saw in question 2? And I would say it's different because we have an a value this time. So there is a 2 in front of x squared. In every other problem that we've done, there's not been a number in front of x squared. Technically, the number in front of x squared up here is 1 in every single one of these examples. So that's what makes this different. So what that means is we're going to rewrite f of x by factoring out the greatest common factor first. All right, so it means I have to find the greatest common factor between 2, 4, and negative 48. Here's the thing, though. The only factors of 1 and 2 are the only factors of 2 are 1 and 2. Which means I don't actually care what all the factors are of 4 and all the factors are of negative 48, because the biggest factor that the 3 could have in common, potentially, is 2. I can't have a GCF that is bigger than 2, because numbers that are bigger than 2 would not be factors of 2, unless you're looking at a decimal factor that would go with that. So yeah, 2 is a factor of 4, it'd be 2 times 2, and 2 is a factor of negative 48, it'd be 2 times negative 24. So my GCF is 2. So if I divide 2 by each term by 2, I would get x squared plus 2x and then minus 24. And then it says now factor completely. So what that means is I'm going to keep this coefficient, this GCF, of 2 out front. And then my job is going to be to factor this remaining trinomial, these 3 terms, just like I factored all 3 problems in number 2. Okay, I'm going to split this x squared up as x and x. I'm going to find factors of negative 24 that add to 2. And so I think that those are going to be 6 and 4. So I think a plus 6 and a minus 4 will do it. And I'm just going to do a quick check, right? 6 times negative 4 is negative 24. And let's see, negative 4x and 6x gives me that positive 2x. So this works. So this would be my completely factored answer. Okay, now let's take a look at a couple other cases here. And 4A says, 4A, B, and C, it says, consider each of the following below. What do you notice? So I have x squared minus 4, x squared minus 36, 9x squared minus 25. And I noticed that they are all missing that bx term. That middle term. Like when I look at the problems up above, all these problems up above here all have this like bx term. The problems down below, none of those have a bx term, okay? And so what that means is that I could rewrite all of these as like 9x squared plus 0x minus 25. Or I could rewrite this as x squared plus 0x minus 36. Or I could write this as x squared plus 0x minus 4. I can rewrite that middle term as a 0 term so that it looks as though I have a bx term, okay? And so that's what it says. Rewrite each as a trinomial and then factor. So I'm going to rewrite x squared minus 4 as x squared plus 0x minus 4. And now I'm going to factor, right? I'm going to break this down into my 2 groups. X squared gets broken into x and x. And I need factors of negative 4, but they're going to add to 0 this time. All right, so remember, I got negative 1 times 4. I've got negative 2 times 2, right? Or I guess I could say 1 times negative 4. But I need these to add to 0. So if I add either of these, I'm not going to get 0. If I add these together, though, negative 2 plus 2, I do get 0. So I'm going to have x minus 2 and x plus 2 as my answer. And again, you can multiply these out or you can check in Desmos. All right. So again, I'm going to rewrite this as x squared plus 0x minus 36. And now I want to factor. And I want numbers that multiply to negative 36 but add to 0. And again, because they multiply to negative 36, I need a positive and a negative number, factors of 36. But I want them to add to 0, so they're going to have to be the same number but opposite signs so that they would add to 0. So it's x minus 6 and x plus 6 would work here. And finally, I'm going to rewrite this as 9x squared plus 0x minus 25. And I'm going to split this into two factors. Now, this one feels a little bit different because I'm not just splitting an x squared. I have this 9 here. Okay, so that makes things a little bit different. I do need numbers, though, that multiply to 25 and are going to help me add to 0. So that feels kind of familiar. Feels like this might be a minus 5 and a plus 5, so I can get that 0. But that 9x squared, I have to be able to split that up. I mean, I could try 9x and x, so let's talk about that. If I do that, I've got to do my multiplication check, right? We can do our box method to check. And if I do that box method to check, I end up with that 9x squared. And I end up with a 45x and then a 5x here. And that 45x and that 5x are not going to give me 0. So that's not going to work. So the other way I could split up that 9 is by using 3x and 3x, which seems reasonable because 9 and 25 and 36 and 4 are all perfect squares. So let's do the check on this one. Let's do our box method check. I got a 3x minus 5. I have a 3x plus 5. And so if I check this, I still get that 9x squared, and I get a 15x here. Because I'm multiplying the same numbers together, I'm also going to get a negative 15x here, and those will add to 0. And so it turns out that when I have these differences of two numbers, I'm missing this middle term, I should have perfect squares. And I'm going to break those factors down into the product of a number times itself. I'm going to use the square roots of these numbers to complete my factors. Makes them feel a little different or a little special. All right, so let's talk about some quick notes here. And the quick notes that I'm going to write down for you include this. A reminder that factoring means that we are going to rewrite the expression as multiplication. So to factor means that we rewrite the expression as multiplication. Okay. And so what that means is that if I have x squared plus bx plus c, that's going to equal my factored form. Okay. And so remember that this is standard form. And this is factored form or intercept form. Okay. The other thing that I want to comment on, though, is that sometimes there's a GCF. So sometimes you are given ax squared plus bx plus c, where that a value is something that is not equal to 1. So it doesn't just show up as x squared, but there's actually a number in front, okay? And so a would be the GCF, often, not always, okay? Which means that you're looking for a GCF. So we're going to just say look for a GCF. And what that means is after I look for the GCF, I'm going to take this ax squared plus bx plus c, and I'm going to rewrite it as some number in front, okay? And then I'm going to have some x squared plus my x term plus my constant. And then I can break that down even further. So I'm going to say this is my GCF. And I'm going to break that down even further so that I have my GCF, but I'm going to take this and I'm going to split it into those two groups. where I have this x and x, and then plus or minus some numbers, okay? Okay, so let's take a look at 2 examples, and then I will let you practice. This first example says, first we're going to factor out a GCF. And so between the numbers of 2, 6, and 36, my GCF is 2. So I'm going to rewrite 2 times, and I'll do this in a different color so it stands out. If I divide each term by 2, I get x squared minus 3x, and then minus 18. And so then my next step is to break this further. So I'm going to rewrite my 2. And I'm going to break this further into my 2 groups that we've been practicing. Okay, so I'm going to break x squared up into x and x. I'm going to find factors of negative 18 that will add to negative 3. I believe x minus 6 and x plus 3 will do it. And this is my completely factored form. Let's take a look at an example when the a value is negative. So we've been talking about the fact that if my leading coefficient, this a value, is negative, then I want my GCF to be negative. And I want my GCF to be negative because when I go to factor, like we did over in this example, this first example here, it is way easier to talk about factoring when that x squared term is positive than it is to try to figure out when the x squared term is negative. And so in this case, my GCF is just negative 1. And so I'm going to write negative 1. And then I'm going to write what's left over when I divide by negative 1. And I have a positive x squared, a plus 7x, and a minus 18. And so then I'm going to now go further, and I'm going to factor that expression down into 2 groups. X squared gets split into x and x. And I need factors of negative 18 that add to 9. And I believe this is going to be a plus 9, and then an x minus 2 is going to do the trick. And so this would be my completely factored answer. Okay, so your job is to try the remaining problems and let me know if you have questions.